All right, in this video, we are going to talk about section 3.1, and that is about measures of center of a data set. So the three measures of center that we're going to talk about are the mean, median, and mode. These measures of center, like the name implies, tell you about where the center of a data set is located. So, or the most typical value of a data set. So the first one we'll talk about is the mean, and the mean of a data set is just the sum of the observations divided by the number of observations. All right, so what you would do to find the mean of a data set is just to add all of the observations up and then divide by the number of observations that you have. All right, so this is example problem 320 from our book. It says, an article by D. Schaefer et al., Journal of Tropical Ecology, reported on a long-term study of the effects of hurricanes on tropical streams of the Luquillo experimental forest in Puerto Rico. The study shows that Hurricane Hugo had a significant impact on stream water chemistry. The following table shows a sample of 10 ammonia fluxes in the first year after Hugo. Data are in kilograms per hectare per year. Okay, so what we need to do to calculate the mean is to add all these observations up. So that's what we're going to do. I'm going to use Desmos and add this up. So 96 plus 66 plus, and I'm going to have to look back at the observations, so I'm going to pull this off camera. 147 plus 147 plus 175 plus 116 plus 57 plus 154 plus 88 plus 154. All right, so add all those up and I get 1200. Okay, when I do that. So that's the sum of the observations. All right, and then I need to divide by how many I have. It tells us we have 10 here, or you can count them up if they don't do that, and you would have to count those up. So 1200 divided by 10 is 120. So the mean would be of this data set would be 120, right, kilograms per hectare per year on this one. Right? So just add up all the observations, sum them up, and then divide by the number of observations that you have. All right, the next measure of central tendency that we'll talk about is the median. So the median of a data set is the number that divides the bottom 50% of the data from the top 50%. So kind of like the middle, the very middle observation. All right, to find the median of a data set, what you need to do first is arrange the data in increasing order. All right, and then what you do from there depends on whether or not you have an odd number of observations or an even number of observations. So if the number of observations is odd, right, there's going to be a number that's exactly in the middle of the list. So that's all you have to do is find that number that's exactly in the middle. Okay. If the number of observations is even, then there is no number that's exactly in the middle, and so what you want to do is take the mean of the middle two observations in the ordered list. All right. So let's take a look at that example of how to do this. Okay, so let me write down these numbers. All right, so we have 3, 8, 2, 9, and 4. All right, so the very first thing that we need to do is to put these in increasing order, right? So 2 would come first, then a 3, then a 4, then an 8, and then a 9. All right, so put these observations in order. right? And then what we're going to have to do is see if we have an even number or an odd number of observations. So in this case, we have 5 observations, right? And 5 is an odd number, so that means that there is a number exactly in the middle. That number that's exactly in the middle is this number 4. So in this data set, the median is 4. Okay. Okay, so that is the median when you have an odd number of observations. Okay, and next up we will take a look at this hurricane data again in problem 320, and we will find the median of this data set. So again, what we're going to have to do is to put these in order. Okay, so let me clear that out. All right, so I'm going to go through and order this data set and write them down in order. So the smallest number here is 57. So I'm going to write that down. Then it looks like the next smallest is 66. Then 88. All right, then 96. So I'm just writing these down like so in order. All right, after 96 is 116. This one right here. Then 147. Another 147. Then these 154s, 2 of those. And then finally 175. All right, so there are the observations in order. All right, and I have in this case 10, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have 10 observations, right? So that's 10 is an even number. So in order to get the median, when I have an even number, I'm going to take the average of the 2 that are in the middle. So 1, 2, 3, 4, 5, right? So these 2 right here, 116 and 147. All right, so what I would do is add up 116 and 147 and then divide that by 2. All right, so 116 and 147, so that's going to be what, 163 it looks like. Oh, 263, right? All right, and then 263 divided by 2 is 131.5. All right, so that is the median of the data set. Okay. All right, next up is the mode. The mode of a data set is the most frequently occurring value in the data set. So in order to find the mode, you would find the frequency of each value in the data set. So like the frequency distribution that we talked about before. If no value occurs more than once, okay, then the data set has no mode. All right, so it is possible that there is no mode. And then otherwise, any value that occurs with the greatest frequency is a mode of the data set. So a data set can have more than one mode. All right, so looking at our data set here, we want to find the mode. All right, and so we look and we notice 3 that occurs once, the observation 8 occurs once, 2 occurs once, 9 occurs once, and 4 occurs once, right? So that means that there is no observation that occurs more than once. So in this data set, there is no mode. Okay. In the hurricane data, if we look through, we can see that there are some values that occur more than once, right? 147 occurs twice, and 154 occurs twice. Okay. And that's it. No other observation is repeated. So since 147 occurs twice and 154 also occurs twice, there are 2 modes, 147 and 154. Okay, and so you can have more than one mode in the data set. One important thing to note about these measures of central tendency is that some are what are called resistant and some are not. So a resistant measure is not sensitive to the influence of a few extreme observations. So down here in this diagram, we have some distributions, okay? And some are, this one in the middle is symmetric, right? And then this one is right skewed. This distribution is left skewed over here. And the main thing to note about this is that the median is a resistant measure of center, but the mean is not. All right. So a lot of times when you see, you'll see like median home values reported in for neighborhoods, right? And so and in other governmental studies, then they'll report the median instead of the mean. And that's because of the fact that the median is resistant. So down here in this right skewed observations, in this right skewed distribution rather, I've got some really big values up here, right? Most of the data is over here in the middle, right around here, but you've got some very big numbers that are really far off to the right. So that's why it's called right skewed, right? So if you calculated the mean and compared it and the median and compared the two, these big observations on at the end would really pull the mean to be higher than the median. So that's why they say the median is resistant measure. If you go back and look at our data set, let's see, where was that? Oh, I erased that. But let's say this data set here that we calculated the median of, right? If the last number over here was really huge, let's just say like this big, okay? Then you can look and we would still calculate the median exactly the same way here, right? There's still 10 observations, so we would take the average in the middle too and get 131.5. So that's what they're talking about. This number over here could be huge, but it really won't affect the median in this case. Whereas if you took the mean, right, of these numbers, now because this number is so big compared to the others, and we add that we're adding these numbers up, now the sum of those numbers is going to be huge. And so it would, by changing this last observation, it would make the mean a lot bigger than it was when this is just 175 here. So that's kind of what they're talking about. The median is resistant to these big, what are called outliers. These huge numbers are really small numbers in the data set that don't kind of go with the rest of the data set, whereas the mean is affected more by these numbers. If we have a symmetric distribution, right, then the mean and the median are both going to be right at the middle, okay? If we have a left skewed distribution, that means that there's some really, really small numbers compared to where most of the observations are. And what that is going to do is going to pull the median down. Sorry, not the median, but pull the mean down so that the mean will be less than the median here. Okay. All right. And so again, you'll see lots of studies that report the median household income or something like that. And that's because of the fact that it is a more resistant measure of center. Okay, we need to talk a little bit about some notation before we move on, because we'll see this notation in the next section again, and that's where it's very, very convenient. It looks kind of complicated, but it really is not. All right, so a lot of times we will use letters to represent variables, okay, like x, and then we will use subscripted versions of the variable to represent the values of the variable. So if we have a variable x here, right, and let's say the values were 87, 92, 91, and 88, then what we will do is write that as x sub 1. So this is a subscript, right? x1 or x sub 1, however you say it, is 87, x sub 2 is 92, x sub 3 is 91, and x sub 4 is 88. All right, so that's a common notation. We have a variable, we represent that with a letter, and then the values of that variable are represented by that same letter, just with subscripts. All right. Okay, so that brings us to summation notation. So what summation notation is just a simple way of writing up the sum or addition, right, of a bunch of values. And so what we do is use the Greek letter sigma, the uppercase version, which looks like this. That stands for, that's basically like the Greek version of the letter S. All right, and so S for sum, right, or adding up. So if I have, say, like the sum of the data in the previous example, right, in the previous slide I had 4 observations, x1, x2, x3, and x4. You could write the formula that says add all those up like this: x1 plus x2 plus x3 plus x4. Okay, and so basically this is just a math way of saying add those numbers up. Sigma notation is an even more compact way. So what you would do is put this Greek letter sigma, and basically all you have to think about that is add up, right? That's just telling you to add up, and then x sub I. So if you look, this is the variable x, and it's got a subscript, right? So that would indicate a value. So really all this notation is saying is add up all of the observations. Okay, so you don't have to go too deep into this notation, because there are some other things that we could talk about in regard to that. But really, when you see this, it just says add up all of the observations. That's it. All right, so it looks kind of complicated when you first see it, but really it's just because mathematicians and statisticians in general, we don't want to have to write a lot, right? So because there's already a lot of stuff to write, and so this notation just makes it very simple to write. You just have to know what it means. That's really it. Okay. All right, so that brings us to the sample mean. So when I take a sample from a population, right, that data, those values are called sample data. And then when I take the mean of that sample data, it's just called the sample mean, right? So I've got a sample, I take the mean of the sample data. That's it, all right? So the symbol that we are going to use for the sample mean, right, is a bar over the letter representing the variable. So if the variable that we're talking about is x, right, then the sample mean would be written like this: an x with a little bar over it, and that's just read x bar. Okay, so x bar, whenever you see that, that would be the mean of the sample related to this variable x. Okay. And so another symbol that's commonly used related to samples, right, is the letter n, and that's used to represent the sample size. So the sample size is just the number of observations in the sample. So if you take a sample of size 10, right, then the sample size is 10. and we would use the letter N to represent the sample size. All right, and so now that brings us to this formula here for the sample mean, right? So x bar, remember, that's going to be the sample mean. I take a sample, that gives me some data, and then I take the mean of that, that's the sample mean. X bar is the variable for that. And here you can see that sigma notation. So this says the sample mean would be add up all of the observations and then divide by n. Remember, that's the sample size. That's how many observations that you have. So this is nothing more than kind of a fancy looking formula for the mean, but it's exactly what we talked about before. It says to calculate the sample mean, add up all the sample data, add them all up, and divide by how many you've got. Okay, so it's really not, the idea behind it is not complicated. It's just kind of complicated looking when you first see those things. All right, so let's run through this example. And this is example 330 from our book. All right, it says popular destinations for the newlyweds of today are the Caribbean and Hawaii, according to a recent American wedding study by the Condé Nast Bridal Group. A honeymoon on average lasts 9.4 days and costs $5,111. A sample of 12 newlyweds reported the following lengths of stay of their honeymoons. Okay. And what we want to do is, in part A, find n. Part B, compute the sum of the x sub i's. C, determine the sample mean. And it says round your answers to one more decimal place than was used for the observations. All right, and so here they were to whole numbers. So what we would do is express our answer on part C to one decimal place. Okay, so let's get started. All right, first off is n, and that's the sample size. They tell us it's 12, right? In here, if they didn't, then we'd have to figure out how many are there. All right, so part A is really easy. For part A, n equals 12, and that's it. All right, so the sample size is 12. All right, part B, it says compute the sum of the x sub i's. So in part B, the sum. So add up all of the x sub i's there. And so all we would do is add up all of our numbers. That's just what that symbol means. So let's do that. All right, so I do 5 plus 14 plus 7. And I'm going to do this off camera again. Plus 10 plus 6 plus 8 plus 12 plus 9 plus 10 plus 9 plus 7 plus 11. All right. So I get 108 when I do that. All right, so the sum of the x sub i's is 108. All right, part C. They want to know the sample mean, okay? So the sample mean, right, that's x bar. That's the symbol that we're using. The formula, right, with the new notation that we're using is sum of the x sub i's over n. All right, and we know both of those things, right? The sum of the x sub i's is 108. And n, the sample size is 12. And so that is 12 actually goes into 108 evenly, right? That's 9 times. Okay. And so, but you could just do it like this, 108 divided by 12. You get 9, right? But remember, they also specifically asked about, it says, round your answer to one more decimal place than the usual, than that used for the observation. So it came out to be a whole number. So there's really nothing to round right there, but they want to answer to one more decimal place, which is a pretty common practice, and certainly in our book it's a common practice. So we would use, since our observations were whole numbers here, right, 0 decimal places after the decimal, then we would express the answer with 1 decimal place. On a lot of the quizzes in tests, they'll ask you to round to a certain decimal place on the answers when you take that. Okay, so that is it, I believe, in this. Yeah, so here's some problems to work from the book. Also, there'll be some quizzes as well. Some problems to work on the quiz for this section as well. All right, and that is it for this one.